Okay, awesome. Let's begin. So this is NHT 2022 exam 1. I'm just going to be trying to do this as quickly as possible. You'll have an hour to complete this, but I'm probably going to finish a bit earlier. Do make sure to slow this down or pause at your own pace, just to make sure you understand everything that I've gone through. But without further ado, let's begin. Okay, very standard first few questions. So this here is a very basic example of the chain rule application. This is a composite function, so we could very simply just apply a chain rule to differentiate the inside and multiply by the derivative of the outside. Very good. This one is a very similar premise, except this is a product function. So we should apply the product rule first to get f dash of x, and then find f dash of e. So you'll get something along these lines. So f dash of e will be 2e, log e of e is 1, so plus e, which is 3e. Very good. Find f dash of x given this. This is a very basic idea. Again, we just got to find f of x by integrating f dash of x. So this is the integral of 2 over x plus 1, and then plus 2 cos x dx. This is going to become 2 log e. So this says x is greater than -1, so it should be just x plus 1 here. No need for the modulus because it specifies. And then this will be plus 2 sine x. Cool. So this is f of x, and this is with a plus c. Okay, so we've got to figure out what that constant is. We know that f of 0 is equal to 3. Therefore, you could say, so log e of 1 is going to be 0. So this is going to be, this is just going to be c is equal to 3 because 2 sine x is equal to 0 as well. So we know what f of x is directly. C is going to be 3 there. So it's just going to be 2 log e x plus 1 plus 2 sine x plus 3. Nice. Okay, so we have a sample proportion question. Randomly samples 100 people. Find an approximate 95% confidence interval. Okay, so we know that the 95% confidence interval will be given by, okay, now this I'm slightly rusty with. So this is going to be, there's 10 of these. Sorry, this is, yeah, so this is the mean, subtracting, okay, so this is z times by, yeah, okay. So this is going to be z times by the mean standard deviation of the sample, and it's going to be the mean plus the standard deviation of the sample, essentially. So we know that this proportion is going to be 0.1, or in other words 10 over 100, and we're going to subtract. Okay, so our z value is 2. We also know that we know that this is going to be given by the square root of p times n minus p. Oh, sorry, p times 1 minus p over n. So it's going to be root 0.1 times 0.9 over 100. Okay, and it's going to be the same thing but added as well. So we know that this here is going to become over 10. We know that the top as well, it's going to be 0.09, so that's going to be 0.3. So 0.3 over 10. So that looks a little weird. Plus 2 times 0.3 over 10. And essentially, we're going to get, so that's going to be 0.06. So 0.1 plus 0.06. Okay, cool. So we get 0.04 to 0.16. There you go. Sorry, kind of rusty on that one. So here we have this f of x, show that a is equal to 5, b is equal to -3. So we know that f of pi and 2 is equal to 2, and so on and so forth. So this is a simple simultaneous equation question. So from this we can get that, okay, sine of pi and 2 is equal to 1 if we use our unit circle. So a plus b is equal to 2, and we know that f of 3 pi and 2 is equal to -8. So Sine of 3 pi and 2 is negative 1, so that's negative a plus b is equal to negative 8. Here we can simply add these two equations together. We're going to get 2b is equal to negative 6, therefore b is equal to negative 3, and a is equal to 5. Very cool. That's your answers there. Sketch the graph of f of x. Okay, so f of x is going to be 5 sine x minus 3. That's very simple. So this negative 3 here will be this line essentially there. That's going to be your median line, but also we know that it has an amplitude of 5 and its domain is set to be 0 to 2 pi. So we do need to label our endpoints and all of that fun stuff. So we know it begins at negative 3 essentially. So it begins right here. So I'm just going to write the function here just for reference. Alright, so we know that this thing has a period of 2 pi, and therefore its quarter period is going to be at pi on 2. Okay, so we also know that the shape is very standard. It's going to go up like this, first of all, right? So after a quarter period, so after pi on 2, it's going to reach its maximum because it's going through the median line. We know its amplitude is 5, so it's going to be a maximum up here, something like this. After that, it's going to reach its median after a quarter period. So it's going to go around here. Then it's going to come back down to a minimum after another quarter period. So that's going to be here. Apologies for my horrible drawing. And we're going to get this right there. This is going to be at 2 pi negative 3. And this is also 0, negative 3. You should know that it does start and end at the same spot because it is, the domain is a length of the period. I believe that is pretty simple. It's also asking for the turning points. So this here is at pi on 2, 2, and this is 3 pi on 2, negative 8. Okay, very straightforward graph. State the values of k for which the equation this has no solution for x. So essentially, it is saying no solutions for the for any x-intercepts essentially. So we just need to find the values of k such that there's a vertical translation for this graph having no x-intercepts. So we know that if we move it down by 2 units, or more than 2 units rather, there'll be no x-intercept. And we know that if we move it up by more than 8 units, there'll be no x-intercepts. So we can easily say that k is an element of so negative infinity to 2, not inclusive, no, negative 2, and from 8 to infinity. And we know we don't include those because if we did include these points, then they would be on the x axis, which will directly give you an x-intercept. So that's a no-go for us. So that's pretty much that. Find the value of m for which it's 0, from 0 to pi. Okay, so this is very, very nice. We're going to get from 0 to pi. We know that f of x is 5 sine x minus 3. And then what I'm going to do is, we know that m, the plus m, is essentially just a line m being multiplied by, it's like a rectangle of a height m and a length of pi. So we know it's just going to be plus m pi here. Okay, so what I'm going to quickly do is I'm just going to keep this like this, and this is going to be m pi is equal to 0. Okay, so this is a very convenient way to do this. So this here will become negative 5 cos x minus 3x. Okay, so this will be pi and this will be 0 is equal to negative m pi. Okay, cool. Well, I'll just keep it here for now. What am I saying? I'll just leave it like that. This will become, when you sub in cos of pi, we're going to get negative 1, so that's going to be 5 minus 3 pi. And then minus, when you sub in 0, that's going to be 1, so when you subtract negative 5, it's going to be plus another 5 is equal to negative m pi. So that's going to be 10. Yep, something along these lines. Okay, hopefully that's correct. Either way, I mean, if you do feel like you made a mistake here, you would just quickly put a scribble here and just double check that later. But moving on, so we have this, we're going to have to simplify f of x over f of negative x, which is interesting. So this is simply equal to e to the 1 minus x over e to the 1 plus x. Okay, and it wants us to simplify this. This is very simply just you're just subtracting these two, the two powers that is, and it's just going to be minus 2x up here. Show that f of a, yeah, so f of a times f of b. So this is show that question, you should show everything. So this is e to the 1 minus a times e to the 1 minus b. So when we add those two together, this is e to the 1 minus, 2 minus a minus b. And you could say, how do we show this? So this is going to be equal to 1 minus, that'll be a plus b minus 1. Okay, so you can actually just go to the step directly because, well, if you just split this up into plus 1 and minus 1, then, plus 1 and another plus 1, you can simply get this here. And this here will just be directly f of a plus b minus 1, which is very nice. Solve f of x is equal to 2. Okay, so we could say that e to the 1 minus x is equal to 2. Then we could just take the log on both sides. 1 minus x is equal to log e2. And then x is just going to be 1 minus log e of 2. And therefore, this is just going to be log e of e over 2, because of the 1 is equal to log e of e, and then when you subtract the two log expressions, you can use the log law to divide the two insides, essentially. In a particular city, the probability of snow here is x squared. Yep, cool. So pretty much we just have a basic diagram, essentially. A tree diagram we could do. So we basically have Monday, Tuesday, and yeah, there's just Monday and Tuesday effectively. So the probability that it rains on Monday is x squared. So if the probability that it doesn't rain is 1 minus x squared. The probability that it rains here does not rain here. So this is not raining. This is also these two. Okay, so we'll just quickly write this out. So the probability, if it does snow on Monday, I'm saying rain instead of snow. Well, it doesn't matter, but I mean, I guess small nitpick. So I'll do it anyways. If it does snow on Monday, the probability that it will snow is equal to x on 4. So this is x on 4. This is 1 minus x on 4. And here, if it does not snow, that it will snow, it will be x. Okay, so this is x and this will be 1 minus x. The probability that it will snow on both of these times, this is just equal to this branch here, so you just multiply these two, it's just going to be x cubed on 4. Okay, find the value of x if there's a 25% chance that it will snow on both. Okay, so this is just x cubed on 4 is equal to 0.25. Or you could say this is equal to 1 quarter. Okay, so x cubed is equal to 1 and x is equal to just 1. Very simple. Find an expression in terms of x that gives the probability that it will snow on Tuesday. Okay, so you could say like the probability that it snows on Tuesday is equal to, okay, essentially it's going to be either this branch here or this branch here. We have to calculate both. So very simply, it's just going to become, the first branch is going to be given by x cubed on 4, as solved from before, plus x times 1 minus x squared. And just to quickly simplify this, this is going to be negative 3x squared on 4 plus x, essentially. That's not squared, that's cubed. Yep, that's good. And the value of x that will result in the highest probability that it will snow on Tuesday. Okay, so this is an expression for it, but we do want to make sure that it's not that. So we know that this is the expression for the probability. We just need to maximize this probability, essentially. find the probability for this value. So what I'm going to say is that I'm going to say that p of x be equal to that thing there, so minus 3x cubed on 4 plus x, and we're going to have to find the maximum value of this, right? So I mean, we know this is a cubic, and it's going to look something along these lines. Well, should be the opposite. It'll look something like this, and it'll maximize at a certain point. So we're just going to say p dash of x. We're going to get the gradient function. It's going to be equal to 9 over 4 x squared plus 1, okay? And we're going to say let p dash of x equal to 0. So we're going to say this is simply just going to be 9 on 4x squared is equal to 1. X squared is equal to 4 on 9, okay? So x will simply be plus or minus 2 on 3, but clearly x is greater than 0 as it is a probability, so x is equal to 2/3. Okay, so that is the value of x, and find that probability for this value of x. Yep, so we do need to sub that back in, so we're going to get p of 2/3 essentially, and we will have to figure that out. Okay, so I mean, you could try and factor this, but I don't think that's worth it in this case. So this is just going to be negative 3/4 times, so 2/3 cubed is going to be 8 on 27, and then plus essentially 2/3. So this, very simply, this is going to cancel out to be 9, this is going to be cancelling out to be 2, so this is 2/9, or negative 2/9 plus 2/3. Okay, so that is going to become 6 on the right side, and when you subtract 2, it's going to be 4 on 9. That's the answer, and you have both probability and the value of x. Yep, nice. So consider the function p of x. This is a polynomial essentially. Find the value of a. P inverse of a. Okay, so obviously in this case we do not have an expression for p inverse, and we do not need one. I mean, you could easily tell that you're going to have a very wonderful time trying to find the inverse, but very simply a is just equal to p of 2 because of the inverse property essentially. And so a is just going to be, you could sub in 2, it's going to become 16 minus 8 minus 4 plus 2 plus 1, which is equal to, what is that? So that's going to be 8 minus 4, which is 4, and plus 3 is 7. There you go. Find the value of b. Oh, p of b is equal to 1. That looks like a lot of fun. So we know that b to the power 4 minus b cubed minus b squared plus b plus 1 is equal to 0. I think this is redundant to write, but I will write it anyways. No, plus 1 is equal to 1, that is. And we can simply cancel these two out. This will be 0 here. So now it's just a game of, we need to factorize this. So this is going to be b cubed minus b squared minus b plus 1 is equal to 0. I believe we could simply group these terms together. So this is just going to be, I must write this in square brackets. This is going to be b squared, b squared minus 1, and then this is going to be b minus 1, I believe. Let me just confirm. Yep, that is correct. And this is equal to 0. So we're going to get, so b is equal to 0, or b is equal to plus or minus 1, but b is greater than 0, therefore b is equal to 1. Okay, that's the only valid solution essentially. Find the rule and domain of f inverse. So what we're going to do is we're going to say let x equal f of y. You could say like the swap x and y stuff as well, but this is very simple. So this is y plus 3 over y minus 2. The best way now is to break this down into its components. So just basically expand the fraction. It's very simply just going to be 1. So it's going to be written as, like, I should explain, y minus 2 plus 5 over y minus 2. So that's going to be 1 plus 5 over y minus 2. As you could see that these two are paired together to make 1, and you can get the second part of the fraction here, essentially. Very simple. So we have this, and then all we have to do is solve for y essentially. So if we were to take x minus, we're going to move this here, it's going to be x minus 1. You could swap the denominator and the left hand side, so y minus 2 is equal to 5 over x minus 1, and therefore y is equal to 5 over x minus 1 plus 2. Therefore f inverse of x is equal to 5 over x minus 1 plus 2. There you go. There's nothing else. Find the rule and the domain of f inverse of x, so of f inverse. So we do need to get the domain of this. We know that this thing is defined over its maximal domain, so it's just going to be very simply the range of this, but really, in all simple terms, you can just get the domain of this as well, purely because the other one is defined for its full thing. So this is all real numbers except 1, and yeah, I don't know why I didn't write x as an element of, but yeah, that's pretty much the domain. Cool. Oh, sorry. So we have a function here, very strange looking one, defined from negative infinity to 0, which is important. Find the general solution to f of x is equal to 0. So what we're going to do is e to the x sine x is equal to 0, and effectively this is just saying sine of x is equal to 0, because e to the x cannot equal 0. So yeah, so sine of x is equal to 0. So I mean, if I was to draw a quick unit circle, then I mean it's 0 here and it's also 0 here, right? Because the line y equals 0. So these two angles are, this is 0 and pi, but I mean really it's just 0 plus pi k, and well yeah, that's just going to be x is equal to pi k, where, okay, now this is important, you know that it's defined from negative infinity to 0, so you know that there's no positive solutions to this thing. So this is going to be k is an element of all negative integers, including 0, okay, because it can still be equal to 0, but you do have to only include the negative integers for this, not the positive side. Find the general solution to f dash of x is equal to 0. Okay, so we do need f dash of x here. So f dash of x will be given by, so this is very simply just the product rule. So if you do it, you're going to get this, and well, we can just say that f dash of x equal to 0. So now you could just say, like, you know, honestly, I mean, I'll just write it short, but sine x plus cos x is equal to 0, because you know that e to the x can't be equal to 0, and therefore you can say, well, you could say sine of x is equal to negative cos x, and then if you divide both sides by cos x, this is just going to be tan x is equal to negative 1, and again the general solution. So this one is going to be x is equal to negative 1 will be negative pi on 4 plus pi k, and yeah, I'll just quickly write this properly. So this is going to be pi times 4k minus 1 over 4, and now it's very important to get the correct domain, right? So clearly, again, this is going to be k's negative integer, including 0. Okay, so 0 is possible, but none else, and it should be going towards the negative side. It is important to note, however, that this may be different depending on what value you chose here. So for example, if you did like 3 pi and 4, then you would have to use a different domain here for the k value, but that's pretty much it. Okay, so this looks like a simple integration by recognition question, so you could easily show this here. So the derivative of e to the x sine x minus e to the x cos x is going to be, okay, so if you differentiated the left side, this is going to be e to the x sine x plus e to the x cos x, and then it's going to be subtracting. So this one will become e to the x cos x minus e to the x sine x. And yeah, you can easily tell what this becomes. When you subtract this negative e to the x, it's going to be e to the x 2 e to the x sine x, and you could see that these two become 0. So I mean that's just it. So that's pretty Interesting. Hence find the area bounded. The horizontal axis over negative pi to 0. So the first intercept, so that's pretty much, this here is negative pi, because you can tell, I mean, from the solution to f of x is equal to 0. And they want the area bounded, the function and the horizontal axis. So what they want is essentially this area here. That's pretty not too bad. So that area is going to be given by what? The area is going to be given by, I'm going to write from 0 to negative pi, okay, just to make it positive. Otherwise you could write negative pi to 0, but just to make it positive I'll swap the terminals, and it'll be of e to the x sine x, right? Yep. And cool. So this here is going to be equal to half of, okay, 0 to negative pi. It's just going to be half of this here, because 2 times e to the x sine x is that, so this will be half of it. So just directly copy this, minus e to the x cos x dx. Okay, so this is equal to half, and what I'll write is, I'll factor out the e to the x. This is going to be sine x minus cos x. So negative pi and 0. So if we were to sub in negative pi first, this is half, and this will be e to the negative pi. Sine of negative pi is 0, cos of negative pi is negative 1. So yeah, so I mean negative cos negative pi is going to be what am I saying? Oh yes, this is just simply going to be, so I don't know why I'm blanking, it's just going to be positive 1, so this is just e to the negative pi, and then when you sub in 0, you're going to subtract, so it's going to be subtracting, when you sub in 0 into this, it's going to be 1, so it's going to be negative 1 there, but when you sub in 0 to e to the x, it's going to be 1, so when you subtract negative 1, it's going to be plus 1, and, well, very simply, this here is your area, essentially. I should write units squared. Cool. Consider this function. It's a continuous random variable. Find the probability that, okay. Find x is less than the maximum. Okay, sure. So we know that the maximum value, okay, so this is some version of our original graph that has also been reflected in the x-axis and dilated. So we know like it's going to look something like this now, and you know that the area underneath is going to be 1 because it's a probability density function. You know that this you know that the turning point occurs at negative pi and 4, so you do need to be mindful of that. So we can say directly that xm is equal to negative pi and 4, because that is that maximum point, or the minimum in our case of the other graph. So simply this here is going to be the probability that x is less than xm is just negative pi and 4 is going to be equal to, I can integrate this function from negative pi to that, but I'm going to write this as 2 e to the pi over 1 plus e to the pi. And it's going to be the integral from negative pi to negative pi and 4 of e to the x sine x. Okay, so we already know what the integral of e to the x sine x will be. Okay, so this is just going to become, okay, we have like half out in front of this thing, so we can easily cancel that with this 2 here. So this is going to be negative e to the pi over 1 plus e to the pi, and then in the inside goes what? It's e to the x. So x sine x minus cos x. Yeah, and we're subbing in negative pi. Yeah, negative pi to negative pi and 4. So this thing is just gonna very simply become, okay, so this may take a bit of a second. So this will become e to the negative pi and 4. So this becomes sine of negative pi and 4 is going to be negative 102. So this is going to be times by root 2. Hang on, what? No, so negative 1 on root 2. So this is going to be negative 2 on root 2. That is correct, right? So yeah, it's just going to be times by so negative root 2. My bad. So I'll just rewrite this here, and you're going to subtract. Okay, so sine of negative pi is going to be 0, and cos of negative pi is going to be negative 1, so it's going to be plus, no, so you're going to subtract that value, so it's going to be subtracting negative e to the negative pi, and because this will become positive 1 when you sub in negative pi. Yep, there you go, and you have your very nice looking root, don't you? This has got to be simplified in some way, so this will become how does this simplify? So this is going to be e to the negative pi over 1 plus e to the pi, and I guess I'm going to write this as, okay, so what I'll do is I'll just get rid of all the negatives just to make my life a bit easier. This will very simply become, I write another negative as I just say it, then plus e to the pi. So you could multiply, so this is just e to the pi over 1 plus e to the pi, and this will be root 2 e to the 3 pi and 4 plus 1 over e to the pi, and you can see that these two cancel directly, so this is just going to be root 2 e to the 3 pi and 4 plus 1 over 1 plus e to the pi, and this should be the probability that you get. So I did go through this decently quickly, I think. So I don't know, I may have made a mistake. If you do catch a mistake, do let me know. I probably will correct this myself anyways, just to double check, but otherwise not too bad of a paper. Hopefully you guys found this a little instructive, and yeah, see you guys on the other side. Bye bye.